what's your exact title for the
Policy Director.
Huh?
Policy Director.
Policy Director of the
Tuolumne River Trust.
Tuolumne Trust. So we will tell you all about our water problems, and I think it was great timing on my part. It's in the newspaper. Might as well take credit for coincidence.
Made it happen, Gary.
I did.
Hey, Gary, can I ask you to advance slides for me since we couldn't get the...
Oh, no, I got it working.
Oh, you got it working? Okay.
Yeah. Yeah.
On my computer?
I didn't tell you, but I did.
Oh.
It just had
These guys, he's amazing.
close that window. Oh, wait, the little switch has to be on.
Okay. And just this button on the side?
That's the one on the
Oh, the
top.
one on the top, yeah. Oh, great, thank you. Well, good evening, everybody. Thanks a lot for coming out. Again, my name is Peter Drekmeier. I work for the Tuolumne River Trust. And our organization was founded in 1981 at a time when more dams were proposed for the Tuolumne. And in 1984, we secured federal wild and scenic status for the upper 83 miles of the Tuolumne. So that meant no new dams, no development along the banks. And we've been working on other issues ever since, including trying to restore the salmon run and making sure that the ecosystem is in healthy condition. And I live in Palo Alto. I live a block from San Francisco Creek. I do a lot of habitat restoration there, so I do love watersheds. I've been involved in a lot of the county water issues as well. So at the end, if people want to talk anything water, I'm happy to try to answer questions. And I know we have a lot of other experts in the room as well. Charles Ice here just completed a groundwater assessment in San Mateo County, which for the first time we really understand the groundwater basin there, and that's going to be more important in the future. So, how many people have heard of the Bay Delta Water Quality Control Plan? Okay, about half. All right. So just a little bit of background. I think a lot of people are familiar with the Bay Delta. So the Sacramento River Basin drains the northern half of the Central Valley, the San Joaquin Basin, the southern half. Tulare Basin, there used to be a lake here that was the largest lake surface area west of the Mississippi. And that water just got diverted from all the tributaries and it dried up. So it's pretty rare that water from the Tulare Basin makes it into the San Joaquin now. But the Bay Delta drains, it's about 40% of California and 50% of the water that falls on the state. So it's the largest estuary on the west coast of the Americas, so the rivers come together in the Delta and it's connected to the San Francisco Bay there. And the Delta is home to more than 500 different species, so really thriving. I think people know that St. Francis, or San Francisco, was the patron saint of animals and the environment, so it's pretty fitting that the Bay Delta, when the early explorers, European explorers came here, just the bounty of wildlife amazed them. And the connection there with St. Francis is kind of nice. It's a major stopover for the Pacific Flyway. It's the migration corridor for anadromous fish that start in freshwater, move out to the ocean, and then come back to spawn, like salmon, steelhead, sturgeon. And we used to have more than 1 million salmon spawning in Central Valley rivers, and that's been in very serious decline in the last few decades. And a lot of people paint it as a fish versus farms issue, but it's really about a whole ecosystem that has evolved around salmon. So the salmon life cycle is they start in freshwater. As juveniles, they out-migrate during the spring when all the water is coming out of the Sierra, and then live in the ocean for a few years, where they get really big because there's a lot more food in the ocean. And when it's time for them to spawn, which is usually after about 2.5 years, they stop eating and they come back to their natal stream. They can actually smell their stream because there are different sediments in the water. And the female will lay about 5,000 eggs. The male will fertilize them and then they die. And the animals will eat the carcasses. They'll spread all these nutrients from the ocean onto forest land, meadowland, even agricultural land. So they're fertilizing the inner part of the state. Now, of the 5,000 eggs, only about 2 will survive on average to become reproducing adults. So it's replacement value. And so most of the eggs are eaten by other species. Most of the juveniles are eaten, most of the adults are eaten, so they're feeding a whole food web. Really, really important. Very important to human beings for a long time. The Native Americans ate an estimated 8.5 million pounds of salmon from the Central Valley. And it helped fuel the western development of California following the gold rush, great protein source. And even today, it's still an active commercial fishery. About 2,200 jobs and about $250 million coming in each year. But the Delta's really changed over the years. With the gold rush came agriculture, irrigation districts creating dams. A lot of the water that would naturally flow into the Delta has been diverted. Levees contain it in certain areas so you don't have all the flooding that took place. Sediment is now captured behind dams and is not making it to the bay to rebuild shoreline. So we've seen it's a very altered ecosystem today. And then a tremendous amount of water is exported from the Delta, including to Santa Clara County. 25 million Californians get at least a portion of their water from the Delta, so about 2/3 of the state. So we're seeing a lot less fresh water flowing into the Delta and the bay. And in an average year, only about 1/3 of the natural flow, the unimpaired flow, what would be there in the absence of dams and diversions, flows down the San Joaquin into the Delta. So it's changing the salinity balance of the Delta, etc. The amount of fresh water reaching the bay is only about, in an average year, about 50% what it would be without dams and diversions. So it's changing the salinity balance. There's a mixing zone that's really critical for the creation of plankton. So the food web from the base all the way up to marine mammals has been impacted by this. Between 1974 and 2014, in a 40-year period, naturally there was only 1 year where the bay was facing super critically dry conditions. That was 1977, very, very dry year. But because of all these diversions, 19 of those 40 years, the bay saw these super critically dry conditions. So the bay delta is a very altered ecosystem. A lot of non-native species that evolved and but now house the ecosystem are taking over, and we're seeing a real decline in the native species. You might have heard about the toxic algae blooms in the Delta a few years ago during the drought when very, very little fresh water was making it in. It's actually not algae, it's cyanobacteria, and they produce neurotoxins that can kill wildlife, make people sick. And so it was a very visible result of this lack of freshwater inflow. And then the problems extend all the way up into the rivers that feed the Delta. As more and more water is diverted, not only is it kind of a hassle for recreation, but it impedes fish passage, the temperature of the water quality, rearing habitat, so floodplains off-channel that are critical rearing habitat for juvenile fish are not inundated enough. So we've seen a real difference in the ecosystem of the rivers that feed the San Joaquin and the Bay Delta. 2015, very, very dry year after several other dry years. And you can see the unimpaired flow. What would be there in the absence of dams and diversions is the blue. And what was actually in the river was red. So there's a baseline right now that they have to make sure there's a certain amount of water in the Tuolumne River so that it doesn't dry up, so that fish can survive. And basically that's all they released. And then you see a little pulse release here. The idea of that is that's the spring pulse flow that if it were significant enough, it would help the outmigration of the juvenile salmon. This probably served really no purpose. It was such a small amount. And then there was no fall attraction pulse flow. So when the mature salmon are coming back to spawn, it's in the fall, maybe around October, early November. And what you want to do is you want to send a signal, a cue, into the Delta that the Tuolumne is this way, come on and spawn. And there was no pulse release, fall attraction pulse release that year. On the Stanislaus, which is the river just north, downstream, feeding the San Joaquin, there was a pulse flow. And they had 12,000 spawning salmon that year. On the Tuolumne, we had 453. So probably a lot of the Tuolumne salmon went to where the water was. And we call that straight. We found a wetter pasture. Whoops. Okay. So water temperature is a huge part of flow, real connection. This is a photo from the Klamath River in 2002. People might remember there was a lot of pressure from farmers in southern Oregon to get more water for their farmland. The Bush administration diverted a lot. The water heated up downstream, and 70,000 salmon died before they could spawn. So that's a very serious issue. And the salmon, the mature salmon, need water to be able to get to their spawning grounds, and then it's really critical for the juvenile salmon to have flows that are high enough to flush them out, because they don't really make a beeline for the delta. They actually point upstream and they count on the current taking them out. And if it's faster, it might be murkier, there's less chance that some other bigger fish will eat them. If they have the floodplains there, they can hide from predators. There's a lot more food in the floodplains. They can get bigger, and then they have a much better chance of surviving. And then the bottom line is we have altered the ecosystem so much that we've turned it from a fast-moving, cold Sierra stream to a very slow-moving, warm stream. And species that have evolved in those conditions, like water hyacinth, which is non-native, just took over miles and miles of the Tuolumne and other rivers during the drought. And you can see it wasn't very fun to go boating on the Tuolumne. It made it very difficult for the salmon and sealant and other species to migrate through this area. And then underwater, you have things like bass, which are non-native. And they prey on juvenile native fish. So what we found is in bigger water years, the bass get flushed out. If it's cool in the spring, the water's colder in the spring and summer, they can't reproduce. So we've altered the ecosystem. And what you hear a lot from the irrigation district in the Central Valley is it's not about flow, it's about these predators. We need to somehow kill the predators. It's like, well, that's going to be a tough project when you have an ecosystem that favors them over the natives. So this graph shows the correlation between flows and the success of juvenile salmon. So the gray bar is escapement, which is the mature fish coming in to spawn. So I guess they're escaping commercial fishers or something. But they're coming in to spawn. And then the dotted line is the flow, and it's shifted by 2.5 years, because when you have high flows, you have a lot more juveniles making it to the ocean. And then in 2.5 years, when they're mature and come back, you see those numbers. So that's when you really see the impact. On the Tuolumne, in 1983, or 82-83, we had the biggest water year on record. And in 85, 2.5 years later, we had 40,000 salmon return to the Tuolumne. 97-98, another really big water year. There's flooding in Modesto. In 2000, we had 18,000 salmon return. Then we got down into the thousands and hundreds since then. So we've seen that correlation happening on the Tuolumne. And in 2008 and 2009, the salmon in the ocean were so few that the commercial salmon fishing season had to be canceled for the first time in history. So historically, we had 10,000 commercial salmon permits. Now we're down to about 2,000. 22 people went without work those years, and $250 million was not added to the economy. So the Bay Delta Water Quality Control Plan. This was required by the Federal Clean Water Act, and the first plan was implemented in 1978. And it's supposed to be reviewed every 3 years, but it hasn't been substantially changed since 1995. So it's been 23 years we've been operating on the same plan. Joe Simidian, who's going to be honored at Guardians of Nature, and is a great guy, I encourage you to come. In 2009, when he was a state senator, he co-sponsored the Delta Reform Act, and that kicked things into gear and required this update to the Bay Delta Plan, which so it's been 9 years now, and there was a lot of work done before that. So these issues take quite a while. And I also have to point out that the Bay Delta Water Quality Control Plan, which we shortened to Bay Delta Plan, is not the California water fix, which is the twin tunnels. And the water fix used to be called the Bay Delta Conservation Plan. So anytime you said Bay Delta Plan, it was like, oh yeah, twin tunnels. Everyone's heard of that. This one, not so much. And just a little reminder, the idea behind the water fix is that there's a problem in that most of the water coming in the Delta is coming from the Sacramento River, about 70%. And you can see it enters the Delta downstream, and the Delta pumps are so powerful that they actually create a reverse flow, and they suck water upstream. And you can imagine that's very confusing to juvenile salmon. And they get sucked into the forebay area there, and all the predators are waiting to consume them. So on the positive side, the idea is to take water from the Sacramento River and get it closer to the Delta pumps to help alleviate some of that problem. But the threat of it is that, hey, once you have this infrastructure in place, and these are 40-foot tunnels, that we're going to be diverting a lot more water from the Sacramento and sending it down south. So most environmental groups are opposed to the twin tunnels. There are some that support it for the potential benefits. That's not what we're talking about today. So I think everyone, all parties agree that the Bay Delta is an ecosystem in crisis. Felicia Marcus is the president of the State Water Resources Control Board. Really smart, hard-working woman. We've got a great water board right now. So this is really, I think, our last best hope to restore the Bay Delta and the rivers that feed it. And they've broken it into phases. So phase 1 is focusing on the San Joaquin Basin. Phase 2, which they're starting, will focus on the Sacramento Basin and some other issues like Delta outflow, water coming into the Delta and making sure it gets all the way to the bay instead of getting sucked out of the pumps. So phase 1 is the San Joaquin Basin. And the environmental document is called a substitute environmental document. It's like an environmental impact report. Was initially released at the very end of 2012. There was a comment period. There were hearings in March of 2013, and the State Water Board said, this is a really controversial issue. We've got to have the best science possible, and they sent staff back to do a lot more analysis. Then the drought hit, and things really slowed down. So it wasn't until September of 2016 that a new SED, environmental document, was released. So that's what we've been working off of until July 6th, when the final environmental document came out. We'll talk a little bit more about that. So what they were looking at with phase 1 is requiring a percentage of unimpaired flow on the 3 main tributaries to the lower San Joaquin. So the Stanislaus, the Tuolumne, and the Merced. And you can see here the Stanislaus is a little bit higher currently because it's part of the Central Valley Project overseen by the federal government. And so there was a little bit more control over the releases. And there's a requirement that there's a certain flow that reaches this area for analysis. And so we've been leaning on the Stanislaus to produce a little bit more than its share of that. And for the Tuolumne, you can see only 21%. This is between the months of February and June. Only 21% of the Tuolumne makes it to the San Joaquin in an average year. So people take 4 out of every 5 gallons. Is that fair? Most kids would say, well, maybe 50-50 would be fair, but 20-80, not so fair. And the Merced slightly higher. So early in the process in 2010, the State Water Board did a flow criteria study and determined that in the absence of other beneficials, if we're just looking at fish and wildlife, we probably need 60% of unimpaired flow in the San Joaquin River and 75% in the Sacramento River. So it wasn't a recommendation, and they acknowledged that there's agriculture, there's urban uses, there's hydropower, but the science tells us 60% for the San Joaquin. What was recommended, and we actually had a slight victory between 2013 when they were recommending starting at 35%. When they came back in 2016, they went up to 40%. So it sounds like the environmental argument persuaded them to go a little bit higher. So it would be 40% of unimpaired flow between February and June. And again, those are critical months for juvenile fish rearing and outmigration. So in 2016, which was an average water year, the blue is what the unimpaired flow was, and the red was what was actually released into the river, and black is what would have been released had there been 40% of unimpaired flow. So the delta between the red and the black is what the improvement would be in the Tuolumne River. There's some flexibility. The range will actually be between 30 and 50%. And it depends on if other measures can